It turns out that for all of the conic sections we were working with, not just the parabola, we can express them in terms of the distance between a point and a line. I know that when we were dealing with the parabola, we had the focus and the directrix. But when we dealt with the ellipse and the hyperbola, instead of dealing with the directrix, we dealt with two foci. It turns out we can still use a directrix. Gesundheit. I know when we set this up with a parabola, what did we say about the two distances? The distance from points on the graph to the focus as compared to the distance to the directrix. As a matter of fact, every point on the curve is the same distance from the focus as it is to the directrix. That's what makes a parabola, is that those two distances are exactly the same. So if we were to say that our focus is F and our line for our directrix is L, then the distance from any point on the graph to the compared to the distance from the point to the line is equal in a parabola. Another way to say this is to take the ratio of these two distances. The distance from the point to the focus divided by the distance from the point to the line for a parabola is exactly 1. If I change that ratio, I get a different picture, right? So let's generalize this and call this ratio, we're going to call this E. And this is short for eccentricity. Now it turns out that there's a separate definition of eccentricity for an ellipse and a separate definition of eccentricity for a hyperbola, and they turn out to be equivalent to this. And that actually turns out to be the easiest defining characteristic difference between an ellipse, a parabola, and a hyperbola. An interesting historical note for you. The word hyperbola is used in English and grammar and composition. When you talk about somebody writing or speaking or being hyperbolic, what does it mean? They're over the top, right? they're too big. Hyperbola comes from a Greek geometry term, meaning we have stuff left over. We're too big. An ellipse comes from being under. And parabole, P-A-R-A-B-O-L-E, is on. The version of equals. In old Greek, Latin texts, those were geometry terms before they were English terms. And it turns out that those match exactly our descriptions here for these sections in whether we are under the distance or over the distance, and our dividing line being exactly equal gives us a parabola. In the textbook, there is a lovely set of algebraic exercises where they work through the entire process of starting with an equation that looks like this and turning it into a polar equation. I don't want to go through this. It's a geometric construction. It's here on page 683. They have a directrix, x equals some number. They put the focus at the pole, and then they try and figure out equations for these distances and match them up. But the net result is that I can write every form, whether it's a parabola, an ellipse, or a hyperbola, in polar coordinates in the same way. Every single equation, ED over 1 plus E cosine theta, or maybe it's 1 minus, or maybe it's sine instead of cosine. These three other options could be down here, is a polar conic section with a focus at the pole. Remember, ellipses have two foci. Hyperbola has two foci. It's only parabola that has one. And directrix x equals d when it's cosine. What if it's sine? Negative is going to come regardless of whether it's cosine. When it's cosine, it's going to be the plus or the minus in front of the e that tells me whether d is positive or negative. Aha, because I'll be going the other way. And the e tells me what kind of conic section I've got. So if the e in this problem is less than 1, I've got an ellipse. If the e is bigger than 1, I've got a hyperbola. If the e is exactly equal to 1, I've got a parabola. E times d. An example. I'm going to make this plus instead of minus so that we're actually working with the formula we started with. Before we go any further, I'm giving you an equation. I want to know stuff about it. Graph this stuff. In polar mode, let's talk about this from the picture. The first question, did you get a conic section? Ellipse, a parabola, or a hyperbola? Because the most common mistake that people make is they don't put parentheses around the term in the denominator, and then they get 10/3 plus 2 cosine theta, and that doesn't look like one of the things we want. So I got that. But that's an ellipse. And that means I should have an E that is smaller than 1. Why don't I see that E being smaller than 1 here? Promise there's a reason. Now that would be up here, right? But on the bottom, it's just 1 plus E or 1 minus E sine theta cosine theta. My problem is that it's not 1 down there at the moment. It's 3. It's 3 plus 2 cosine theta. If I want to compare this to the standard version of the equation, that denominator has to either be 1 plus or 1 minus a trig term. So I'm kind of stuck at the moment. It's a 3. I got to get rid of the 3. Let's divide everything by 3. Aha. My eccentricity, 2/3 less than 1, I have an ellipse. And I can tell you what the directrix for this ellipse is. What's the directrix? Now I need the top. That is ED. But we know E is 2/3. So what's D? Bingo. And that means my directrix is the vertical line x equals 5. Now, wait a minute. In a parabola, we said our curve goes around the focus away from the directrix. Our curve goes around the focus. The directrix is a vertical line over here. That makes sense. It goes around the focus away from my directrix. My directrix being way over there on the right pushes this hyperbola. Ellipse. That's what it is. It's an ellipse. Pushes the ellipse off to the other side. I know 2 other things about this particular graph. Question?
How many squares? I had like this before, since I divide 10 minus 3 plus 2 cosine theta.
Have to divide everything by 3. So if you, that's why you have to divide the whole thing. So you've got to make sure there are parentheses there. And that's what gives you the correct graph. I know that where one of the foci is. Ellipse has 2 foci. foci that I know about, the focus I know, is at the origin. An ellipse is the path taken by that throw, that yo-yo, with my hand as the focus. Right, it goes behind my hand as it comes around. I'm not good at this one. A lot of people can do this over and over and over. But I claim this is an ellipse. On Monday, we had a different version of the equation of ellipse, right? What was the equation for an ellipse that we looked at on Monday? That you all downloaded and looked at the form on Canvas and printed it out so you have all of those equations to look at? Or that you look at the app on your calculator and find it there? The form of the equation of an ellipse. Say that one again. X minus a squared over a squared.
Plus y minus a squared over b squared.
And a is bigger than b means the a is the long direction, is under the x. Great. So I know that this should somehow relate to this. And one of the questions I often get is, well, can I switch? Can I move from a polar equation to an xy Cartesian equation? Because I like x and y better. Those are easier to deal with, even though this equation is messier than the polar one. And the answer is yes, provided we can find four numbers. I need h, I need k, I need a, and I need b. How am I going to get those? Oh, wait a second. Didn't those numbers go with things on the graph? Something about a box. Yeah.
Would be under codex and then ellipse.
But that would only help if I knew what the HK, A, and B were to put it in there in the Connex app. But there was a box. When I drew the ellipse by hand, I made a box. Where the hell did the box come from? Did it on Monday on purpose. Even though I said that my sketch was bad, I still drew the sketch. Yeah?
Is this one that came from the foci and the major vertical and
The foci were inside the ellipse. The box went all the way to the edge of the ellipse. So it didn't come from the foci on the minor axis. It came from, what did we call those 2 points on the outside edge? These 2 points. They were the vertices. And on the equation, the vertices came from A, and the minor axis parts came from B, right? And the foci came from C. So I actually have the information I need to get some of these. Question for you. That's a vertex, that point right there. What are the coordinates of that point? But I can find out, what angle is that? In polar coordinates, what angle is that? Yeah. So I hit trace, and I put in 0 for theta. And it tells me that point is 2, 0. There's another vertex. At what angle? Pi. So I hit pi for an angle, and it tells me that's the point -10, 0. In xy, or in polar, it would be at 10 pi. Okay. That means I know the major axis. Going from left to right is how far? And that means that the middle is halfway between those. Where's the middle? Because we got to go 6 units from -10 or 6 units from +2. That means that the center is right there at -4, 0. What letters do those two numbers go with? -4 and 0. That's exactly right. But wait, I know one more number in here. I only have H, K, A, and B, and I'm telling you I know one more of them. It's either A or B. Which one goes from the center to a vertex? A or B? Because that's the longer one. A is bigger than B. And so that tells me A is 6. I'm 90% of the way there. The question is, how do I find B? The answer is indirectly. I know another number that's not in the equation, but it's still something we use. Another distance. I talked about drawing my ellipse with thumbtacks and string, right? We looked at where the foci were. What letter did we give the distance from the center to a focus? Patty, weren't you telling me you liked the fact that we were reviewing? That means I should remember this stuff. K was from, that's the y coordinate of the center. In an ellipse from the center to a focus. Gave that a letter. What letter was it? It's on the formula sheet. C. It's even in the word focus. C. So C is the distance from the center to one of the foci. Hey, wait a minute. Do we know where one of the foci is? It's at the origin. How far is it from the center to the origin? That's 4 units. How do I get B? There's a relationship between A and B and C. Exactly. I'm not even going to write down B. I'm just going to leave it as B squared. Because to put it in the equation, I don't need B, I need B squared. I now have everything I need to write the equation in X and Y. X minus H squared over A squared plus Y minus K squared over B squared equals 1. Ta-da! Leo, now you can go into the ellipse thing on apps, and you can put in the H, the K, the A, and the B, and you can see if you get the same picture. Ellipse, X minus H, Y minus K, that one. A is -4, B is, no, A is 6, B is the square root of 20, H is -4, and K is 0. It's the same picture. -2 to 12. Whenever we do a polar conic section in this form, we always have one focus at the origin. You notice I didn't even find the other focus. We could, right? It's 2 units in from the vertex that's on the left side. So the focus has to be 2 units in from the vertex on the right side. A is the distance from vertex to center. The vertex versus the center. How do I go from -10 to 4? Sorry, from -10 to -4, I move over by 6 units, right? From 2 to -4, I move over by 6 units. So that's my distance. C is the distance from the center to a focus. And there's a focus at 0, 0, always in a polar conic section. So from -4, 0 to 0, 0, 4 units. Now, the problem with this setup, the problem with doing this is that you have to have memorized all that crap on that page about A and B and C and what numbers go where, right? That's not the easiest thing in the world to stick into your head. So if you really wanted to, you could find this XY equation a different way. You could take the polar equation And you could use it directly to convert between using cosine. Oh, you're right, it's cosine theta. Thank you. You could use it to convert directly from r and theta to x and y. How? Well, I'm going to have to do a lot of algebra to rearrange stuff. So I start by moving this over, r times 3 plus 2 cosine theta equals 10. And then I have 3r plus 2r cosine theta equals 10. I'll move that over. And now you have to make a decision. You want to leave the 3 on the left, or do you want to divide by it? If I divide by it, I'm going to get some ugly fractions now. If I don't divide by it now, I'll have to divide by it later. But now I can switch from r, theta, to x and y. What's r cosine theta? Sorry, I didn't hear you. Polar to Cartesian. Aha. Then here I get 3 square root x squared plus y squared, because r squared is x squared plus y. Hey, wait a minute, that's an equation now that's all in x and y. And if I square both sides, with a lot of algebra and some completing the square, I can turn this into this. I don't know, do you think that's easier or harder? You don't have to memorize all the A, B, and C stuff, but you got to do a lot of algebra instead. Notice that in this polar conic section, our directrix was on the right, so our curve was mostly on the left. Let me do the same starting question. What kind of a conic section is this? What's the eccentricity? The eccentricity is 1 because this is a 1 already, which means I need the number in front of the trig term. It's 1 plus or 1 minus, excuse me, e sine theta. If the eccentricity is 1, we have a rate. I'm not going to draw anything at the moment. Should this parabola go to the right, left, or up, down? Why? Sine theta, that should be on the y-axis somewhere. So if you graph it, you'll see that's true. So it's either going to go up or down. What's the directrix? Aha, d equals 6. But the equation for the directrix is a line, Jack. It's not a number. D is 6. But is it y equals 6, x equals 6? Or is it y equals minus 6 or x equals minus 6? This is the question that you asked me, Maddie, back when we were looking at the equations in the first place. How do I know if it's plus or minus, up or down? It's the sign of the trig term that tells me whether I should use a plus or a minus over there as 6. The fact that that's subtraction means I should use minus 6. You said up, down. If it's up, down, is the directrix vertical or horizontal? Horizontal. That's y equals negative 6. This should go up. Another way to know or to think about the way that we know this goes up is to think about the difference between an ellipse and a parabola. An ellipse closes back in on itself. A parabola never does, right? That means that there's some point, some angle theta, where that radius is undefined. If we had a parabola going off to the right, then somewhere out here, there would be an angle where we had no point. This one's going up. Put in pi over 2. What do you get in the bottom there? And that means that it's undefined at pi over 2. Our parabola doesn't have a point up there, does it? It goes out to the left, it goes out to the right, it never goes up. And we can actually see that here. If we put in pi over 2, y is blank, it knows it's undefined. Questions? Same starting question. What's our eccentricity? What kind of conic section do we have? A hyperbola. Because my eccentricity is, I have to divide out that 2. So I divide everything by 2. 6 over 1 plus 2 sine theta. My eccentricity is 2. That's bigger than 1. Hyperbola. If I graph this in my graphing calculator, you will notice that my calculator is stupid. Why is my calculator stupid? Because it tries to play connect the dots and ends up drawing the asymptotes. It started here, and it drew down to there, and then whoosh, the next point was way over here. So it tried to connect the dots and ends up drawing the asymptotes, which is a mistake. They're not technically part of the graph. Right? My hyperbola opens up and down. If I were to do the Cartesian equation, would it be x squared or y squared that is positive? Because in hyperbola, it's x squared term minus y squared term or y squared term minus x squared term. Which one goes up and down? X being positive or y being positive? I believe that is correct. How can I check? If I go back to that conic sections app, wrong one. Quit. Apps number 4. I go to the hyperbola section. It shows me the picture. And yes, the positive y squared goes with the up and down hyperbola. Helps to have a way to check. Got turned off. Turn it back on. There we go. But you'll notice where it starts. It starts at r equals 0 and starts drawing, and then draws me out across. If I want the directrix here, what's the directrix? Again, same question. Y equals x equals positive or negative?
E times e equals 6x divided by e.
Right, but Jack said that's 3. So what's the equation? The number is 3. But what's the equation?
Would this be the y
Positive 3, because I'm adding in the bottom, and it's y equals because it would be horizontal. The graph goes up and down, so it's y equals 3. Notice that's up here. The graph goes away from the directrix around the focus. So the directrix in that picture is between the vertex and the center. That way we go away from it in that bottom part. If I want those asymptotes, if I want the equations for those asymptotes, I need their slope. The only way I have to get the slope of the asymptotes is to get A and B from the Cartesian equation. That's why I want you to be able to find a Cartesian equation or to figure out what those two things are. So we could go through and figure that out again here, and then you could tell me what those two lines were. Questions? All right, let's see if I can pull this trick off. You don't want that. We're different angles, right? How do I change the angle? Let's suppose I wanted an ellipse that went that way. Rather than just straight across, I want it to go this way. How do I change the angle in a conic section? By the way, if we were doing this in X and Y, it would suck. But if my conic section is already in polar, changing the angle is a shift. Let me go back and use the ellipse we were looking at earlier. The ellipse we were looking at earlier was r equals 10 over 3 minus 2 cosine theta, right? If we were in X and Y, I could say, oh, to move the X, we add or subtract X. To move the Y, we add or subtract the Y. I want to move theta, I add or subtract on theta. So I want you to graph not this equation, I want you to graph this one. What happens when you graph that equation? We know what this picture looks like. This picture looked like an ellipse that was over here on the left, yes? This one is spun 60 degrees by pi over 3. Oh, because I made a copy error. There we go, 10. It took the same picture we had earlier. It was over here and turned it to pi over 3. I rotated my axis. What if instead of going counterclockwise, I want to go clockwise? Use a plus instead of a minus. Rotation in conic sections is trivial in polar coordinates. In case you think this is a useless idea, I need you to do me a favor and look up a term called precession. In particular, you should look up the precession of Mercury, the planet, not the element, because that tells you how the ellipse rotates over time, and that was one of the things used to prove relativity theory. Congratulations, you're doing rocket science. What are we doing tomorrow? Question and answer on 10.5 and 10.6. Why? Because your exam is Monday. The exam review has been posted for about a week and a half now. So I will see you all tomorrow. Have a wonderful rest of your day.